In the previous lesson, we learned how to use the stoichiometry flowchart. However, if we look at all the conversion factor on the stoichiometry flowchart, some of the conversion factor is not complete. In order to have a complete conversion factor, both sides of the conversion factor must have a number and a unit. Here is an example of a complete conversion factor. That is, we have 1 moles of A equal to 22.4 liters of A. What does that mean? We have the number as well as the unit on this side as well as this side, the number and the unit. And here is another complete conversion factor. We have 1 moles of A equal to 6.02 times 10 to the 23rd represent particle of A. However, if we look at the molar mass conversion factor, we have 1 moles of A, but then we have the number of grams of A. This is not a complete conversion factor because we don't know what is that number. But we learned how to solve for molar mass in the previous lesson as well. To find that number of grams, we had to use the formula as well as the periodic table. Going back to today's lesson, we are going to learn how to use this stoichiometry flowchart as well as using the incomplete conversion factor and solve the whole entire problem. Let's do one problem together. In this problem, I have a beaker containing 33.0 grams of water. This is our chemical formulas right there. How many moles of water are in the beaker? So we know this is our given, which is represented by G. And then our unknown, it is mole. So we can start going back to this basic format. Our unknown is moles of H2O equal to our given, in this case, it is 33.0 grams of H2O. So we always start from our given and end with our unknown. So our given is, in this case, it is grams. So we have our starting point right there. And we are ending at the unknown, which is mole. So this is our ending at that box of unknown. So from start to end, we have to go through this conversion factor, which we have to multiply by. And if we look at the conversion factor, we have moles and gram. If this is gram, this has to be grams of water. So for now, I'm just going to put number of gram of H2O. We're going to solve for this later. On top would be the other part, which is 1 mole of water. And then we are done. We can cancel out the grams of water and give us the moles of water. But wait a minute, how do we determine that number? We have to go back and find the molar mass of the substance, which is water. So what is the molar mass of water? So I'm going to abbreviate molar mass mm of H2O. All you have to do is go back to the periodic table and solve for it. We have H, we have O, there are 2 H and 1 O times the mass on the periodic table. This is 1.01, and oxygen is 16.0 right there. And that gives us 2.02 equal to 16.00. And the total molar mass is 18.02. And this is going to be right there, 18.02. So now we can simplify everything. We have 33.0 times 1 mole. But again, we ignore the 1 because everything multiplied by 1 is equal to self. So we have 33.0 mole of H2O divided by, it's no longer a generic number sign anymore, but now we know it is exactly 18.02. And that is our answer. Let's try another problem. In this problem, we have a beaker containing 1.3 moles of sodium chloride. And how many grams of sodium chloride are in the beaker? In this case, our given is 1.3 moles of NaCl. So this is our given, and we are looking for how many, which is question mark, of sodium chloride, specific grams. So our unknown is question mark grams of sodium chloride or NaCl equal to, what's our given? 1.3 mole of NaCl. And go back to our stoichiometry flowchart. We are starting from mole this time, right there, that's mole. And we're going to end at gram, which is right there. So we go from here to there. So we have to multiply by this conversion factor. In this case, if this is moles, the mole part would be on the bottom, which is 1 mole of A. But what is A? A is the substance, which is sodium chloride. So we have NaCl. Then we have the other part, which is number of grams, going to be on top. NaCl. And then we are done. We can cancel out the moles of NaCl. But what about this number? Again, that is your molar mass. So we go and find the molar mass of NaCl. Using our periodic table, we have Na right there, and we have Cl right there, and we have one Na, and we have one Cl as well. So Na is 22.99, and Cl is 35.45. So we can just add them up together. So we have 22.99 equal to 35.45. We add them up, and what do we get? 58.44. And that is the grams in 1 mole of NaCl. We can cross that out, and we can say, hey, that is 55.44 right there. Now, say this is 1.33 times, not a generic number size, but we know exactly what is that number going to be, which is 55.44 grams of NaCl, and divided by 1 mole, which we can ignore because it's divided by 1. Anything divided by 1 is equal to itself. You see, that's the difference between a generic number sign and a specific number. Now we know how to use the periodic table and the chemical formula to determine that number. Let's try a more challenging problem. A beaker contains 37 grams of calcium chloride. How many atoms of calcium chloride? Well, this would be how many formula units of calcium chloride are in the beaker. In this case, our given is right here. It is grams of calcium chloride, and we are looking for formula unit of calcium chloride. So we are starting from grams, start right there. Always start inside A, and we are ending at where? Formula unit. I don't see formula unit anywhere. Hey, formula unit is right here. It's part of the represented particle. So we are end right there. So we started from here, going down and going across. This is our first conversion factor, and that is our second conversion factor. Let's plug in the equation. We have question mark formula unit of calcium chloride equal to given, in this case it is 37 grams of calcium chloride. And time our first conversion factor is that one. We know this is gram, therefore the bottom part must be the number of gram of the substance, CO2. And the top part must be 1 mole of CO2. That is our first conversion factor. But how do we determine that number over there? Again, use the periodic table and the chemical formula to find the molar mass. So I'm going to do it right there. Molar mass of CaCl2. For Ca, we have only 1. For Cl, we have 2. And we use the periodic table to find the mass. So for Ca is 40.08. For Cl is 35.45. Give us our total mass of each element. We have Ca 40.08, and for Cl is 70.90. And we find the total, give us 110.98. And that number is the mass number in grams right there. So we can erase that and put it right there. So we have 110.98. Now we are done with that conversion factor. Let's move on to the next one, which is this one right here. Time. In this case, this is mole of calcium chloride, so the bottom part must be mole. So we have 1 mole of CaCl2, and the other part must be the leftover, which is 6.02 times 10 to the 23rd. Represented particle, but we know a specific represented particle in this case, which is formula unit, CaCl2. And then we are done. Notice how moles of calcium chloride cancel out. Give us the formula unit of calcium chloride, which is the same thing as our unknown. Now let's simplify everything to get our final answer. The gram of calcium chloride that canceled out a long time ago. So multiply everything on top. We have 37 times 1, so we can ignore that, times 6.02 times 10 to the 23rd formula unit of CaCl2. And then divide everything on the bottom, which is no longer just a generic number sign, but is 110.98. And that is our final answer. Let's try this last problem together. At STP, standard temperature and pressure, a bottle contained 37.5 liters of carbon dioxide gas. How many grams of carbon dioxide gas are in the bottle? So in this case, we have our given. And our unknown is question mark of grams. So go back to our stoichiometry flowchart. We have liters as our given, always start on side A. So this is where we start. And where do we end? At gram, which is all the way up here. So going from liter, which is our given, to the unknown, we have to go through there. This is our first conversion factor, and that is our second conversion factor. Now let's plug this in. We have our unknown as question mark grams of CO2. And we are given 37.5 liters of gas, CO2. So the first conversion factor is this one. 1 moles of A equal to 22.4 liters of A. In this case, if this is liter, the bottom part must be the liter as well. And what's the substance? CO2. And then what is the top part? It's 1 mole of CO2. Notice how the liter of CO2 cancel out. Then we move on to the next conversion factor. Notice how we have mole, so the mole part would be on the bottom. We have 1 mole of CO2. But the top part is the number of grams of CO2. Again, how did we determine the number of grams? That is the molar mass. You have to use the chemical formula, which is CO2, and use the periodic table. So let's find the molar mass for CO2. In this case, C we have only 1, and for O we have 2. And then the molar mass for each of the element of carbon is 12.01, and for oxygen is 16. So for carbon, we multiply by 12.01, for oxygen is going to be 16.00. So the total mass of carbon in this chemical formula is 12.01, and for oxygen is 32.00. And we have a total of 44.01. And that would be the number of grams of carbon dioxide in 1 mole of carbon dioxide. So we have 44.01. Now let's simplify our answer. Before that, let's cancel out moles of CO2 because they cancel each other out. In this case, we have 37.5 times 1, which we can ignore, then times 44.01 grams of CO2. Notice how we don't use the generic number sign, but we know exactly what it is now, divided by 22.4. And that is our final answer. This is the answer that we can plug in a calculator directly.